Hello everyone, my name is Rania and today I will be a physicist explaining to the community about wave interaction and application in real life. So what is waves? So wave is basically a disturbance that occurs in the medium that carries energy. Now there's a lot of type of wave and their interaction, but today we'll be focusing on refraction and interference. We'll start off with refraction. So refraction is the bending of waves from one medium to the other. Now to get a better view of or understanding of what it is, let's do a demonstration. To better understand refraction, we could do a simple demonstration using everyday items such as a glass of water and a straw. Now as we all know, when we put this straw inside the water, it looks bendy, it looks distorted. But why is that? Now, apparently it is because the light traveling from a faster medium, which is the air, to a slower medium, such as the water, bends the way we see it, or bends the way the light wave is projected. Now, another interesting thing, as you can see from the normal line, is that when the light is traveling from a faster medium to a slower medium, we can see that the refracted ray is bending much closer to that of the normal line than further away. However, in this case, this might not always be applicable to all because again, materials are different and we happen to use a material such as metal for this demonstration. So how about a real-life application? I guess one of the few things that you can see refractive being implemented on is glasses, especially those prescription glasses. So how this works is that the glasses help to refract the light wave going into the retina by manipulating it to the eye's need. The fast light waves from outside slow down upon entering the lens that causes it to bend accordingly to your eye's needs. Well, let's look at another example from a different field, now particularly from the mechanical engineering field or just generally the engineering field. Now, this particular field uses a non-destructive testing. So basically the NDT uses techniques such as ultrasound testing to check out the properties and defects of materials without damaging it by using sound waves. It uses the refraction of the sound wave, which happens because of a difference in the material's properties such as densities, to accurately detect defects or other things within the materials. Another field where they utilize as refraction is seismology and geography, which is to understand how seismic waves travel through the Earth's layer. Nearly the same as an NDT, the refraction made by the seismic wave helped geologists and seismologists to understand the Earth's layer even better. Now let's take a look at interference. Now interference occurs when two waves meet while traveling at the same medium. This could either enforce the waves or cancel the waves. Now let's look at a short demo about interference. So one of the few demonstrations to prove interference can be done using this speaker test. So both of these laptops, they're the same spec, so hopefully their speakers are in the same volume. They're both in their highest setting, their highest volume, and they're both playing 300 Hertz. Now, in theory, if I'm standing at the middle, equal length from both of these speakers, I would have a higher frequency. Why? Because this is going to result in a constructive interference. Why? Because their wavelengths is now the same length, so now they're overlapping and they're building the frequency. Because again, the crest or the trough is overlapping with each other. However, if I move a bit to the left or to the right, in theory, we should hear a reduction or a reduce in frequency or in the volume because now the wavelength is not at equal lengths. Therefore, when they overlap with each other, it will be the crest and the trough meeting each other. So we'll now have a cancellation, or as we can also call it, a destructive interference. Let's try it. Okay, now let's move a bit to the left. So how about its real-life application? Well, first of all, we have the anti-reflective coating. So this coating minimizes the reflection of the light wave. The layers of the coating is made to interfere destructively with the incoming light wave so that it doesn't bounce back. The next one isn't the best example, but it does happen, which is signal interference in telecommunications. In the presence of two wireless signals or more, the presence of another wireless signal weakens or disrupts the other signals, basically creating a destructive interference. This discovery helps to create a solution to avoid these such problems such as shieldings. However, the application of interference can also be used to boost signals based on the constructive interference theory. Another place where interference helps is in the acoustic field in the creation of noise-canceling headphones. So how this works is that external sounds entering the headphones are cancelled using headphone-produced sound waves that are 180 degrees opposite of it. The external sound wave, now paired with another wave that is 180 degrees opposite to it, is now cancelled, thus creating a silence effect of the outside noise within the headphones. Now this brings us to the end of the video where I will be answering the big question: why might visionary leadership cause and/or effect transformation? So, through the examples given, visionary leaders are able to utilize a known knowledge to create innovation or further discoveries that can significantly impact the community or transform the way we perceive things. Well, that is all from me today. Thank you very much.